All right, y'all. So section 3.7, it deals with systems of linear inequalities. All right, y'all. So before we deal with the systems of linear inequalities, we're going to learn how to actually graph inequalities. So remember, inequalities are going to be less than, greater than, less than or equal, or greater than or equal. Okay? So graphing inequalities will be the first thing we look at. Alrighty, so the first thing you got to decide on is what kind of line we're going to draw. Do we want a solid line or a dashed line? Because a solid line means any point on the line makes the inequality true, to where a dashed line means points on the line make it false. So, first thing we look at is choosing the line. Okay, y'all, like I said, it'll be either solid or dashed. Okay, so if your inequality has equals in it, if it's less than or equal, greater than or equal, then we're going to use a solid line. Okay, because that means any point on that line makes this true. If it's greater than or less than, so there's no equals on these. If there's no equals under your inequality, then you're going to use a dashed line. Now in MATLAB, when we graph, it'll give us a choice between what type line to use, okay? All right, so there's many solutions to these graphing inequalities, okay? So what we do to represent all the solutions, we're going to shade the graph. So decide where to shade. Now in MATLAB, when we shade, they'll have a little paint can icon and you just drag it to where you want to shade and let go, okay? All right, so we're going to decide where to shade. So if you are greater than and equal or greater than, if the inequality is greater than, we shade above the line. If it's less than and equals or less than, so if the inequality is less than, we're going to shade below the line. Hey, y'all, and I'll just do a little example before we actually get into the MATLAB on these, okay? Now, as far as finding points, I'm going to set up a little table like we did in section 1, find my points. It's when I start graphing it that I got to worry about this kind of stuff, okay? So let's do a little example real quick, such as graph. How about y is greater than x plus 3? Alrighty, so I got my equation set and it's already solved for y. So what I would do is find me a table that I'm going to make, and then we'll graph that over here. All right, y'all, so I'm just going to find me some easy numbers to use. I'm going to use a 0 for my x, because if I put a 0 in, 0 plus 3 is 3 for my y value. And then I'll use a 1 for the x. If I put a 1 in for the x, 1 plus 3 would give me 4. So these just need 2 points on them. And in MATLAB, we would choose the line tool, okay? So for all these, we'll choose the 2-point line tool. Alrighty, so I got my 2 points. Now I need to choose what line I'm going to use. Because like I said in MATLAB, it'll have a solid line and a dash line. So for this one, since I don't have an equals under this, I would use the dotted line, the dash line, okay? So you would plot your 2 points. So y'all let me make this go out about 5. All right, so my first point is 0, 3. So 0 on the x, go up 3 on the y. Then my second point was 1, 4. So write 1 on the x and then up 4. So at that point, since I would have chosen the dash line in MATLAB, when you put that second point there, MATLAB's going to come in and draw you a dash line through there. So we got our line drawn. Now we got to determine where we're going to shade it. So this is greater than. And on shading, we said if it was greater than, we shade above the line. So in MATLAB, you would drag the little paint can above this line here, and it'll shade it all yellow. So since we're greater than, we're going to shade above the line. So that means any point that I pick in here would make this true. Like y'all, here's a point right here I could use just to test it. So this point is 0, 5. So if I put a 0 in for the x and a 5 for the y, this would be 5 greater than 0 plus 3. Well, this is 3, so 5 greater than 3 is true. So any point you pick in here in this shades will be true. Any point that's down here that did not get shaded would make that false. So you can check points if you want to make sure it's true where you shaded that at, okay? But y'all, that's a trick to these. Finding you some points to plot, decide what type of line you want, and then decide where you want to shade above or below. So we're actually going to do some of these in MATLAB now. So let me go to the MATLAB. And let me get us on to our homework for 3-7 here. All right, y'all. So our first one is y greater than x minus 3. All right, so I got my problem wrote down. So we're going to go and work this real quick. And then once we got 2 points, we'll go back and graph it and all that. All right, y'all, let me bring my chat up. So y'all, the first thing you got to decide on is 2 x values you want to put in here. So give me 2 x values that I can use on this. So I got a 4 and then 0, 3. So y'all, I'll use the 4 and then I'll use my 0. All right, so if I put a 4 in here, 4 minus 3 is 1. So that'll give me a y value of 1 on that one. If I put a 0 in there, 0 minus 3 is a negative 3. But y'all, like I said, you're at the liberty to pick any x values you want, okay? All right, I got my 2 points. I'm going to plot 4, 1, 0, negative 3. So I got 2 points. So let's go to Math Lab and see what we need to do. All right, y'all, so I'm going to click to enlarge my graph. All right, y'all, first question would be, do I want this solid line? Now, the solid line is always highlighted by default. If you need a dash line, you need to go right under it and choose the dash line. So for our graph, all we have is greater than. There is no equals on it. So your first choice better be to select the dashed line tool. So I'm going to click it, and it's now highlighted. I'm going to go up here, choose my 2-point line tool on the top row. And now we're going to plot our 2 points. We had 4, 1. So that would be right 4, up 1. And then my second point was 0, negative 3. So start at 0 and go down negative 3. So see, it's drawn my dashed line. So now we got to decide whether we're going to shade it above the line or below the line. So we got greater than on this one. So since it's greater than, we're going to come and highlight that little region shading tool, it calls it, but it looks like a paint pan. So grab that paint can, go over here, anywhere above the line here, and click. Once you clicked it, it will shade in the graph for you. So that means anything that we shaded makes that true, okay? And y'all, then you'll save it. And then you go down here and check your answer. All right, y'all, so that's going to be the trick on these. Now, the second one's a little trickier because they got 4x minus 3y less than or equal to a negative 9. So this one's a little trickier because we really want to solve it for y, then find our 2 points. So on this one, you want to solve this for the y first. That way, if you wanted to use your calculator to get points, you could, okay? So since I'm solving this for y, I'm going to move the 4x to the other side. So since the 4x is positive over here, we would subtract 4x from both sides. So those will cancel. I bring down that negative 3y less than or equal. All right, these are not like terms. So I always put my variables first and then my numbers. So I'm going to make this a negative 4x and then minus my 9. But y'all, order don't matter. You can go negative 9 minus 4x and you'll still get the same answers. Now, y'all, here's where you got to be careful on an inequality like this. Because my y variable is negative 3y. So I'm going to have to come in and divide everybody by negative 3. But y'all, here's a little rule. Whenever you divide an inequality like this by a negative number, you got to take the inequality and flip it. So this less than will now become a greater than or equal. And then I'm still dividing everybody by that negative 3. So remember, reverse the inequality when dividing by a negative number. Now, if that would have been a positive 3, I wouldn't have flipped it. only flipping it when I divide by negatives. All right, y'all, let's see what we get. Negative 3 divided by negative 3 is a 1y. It's now greater than or equal. Well, y'all, negative divided by negative is going to make that a positive 4/3 x. And then this negative divided by negative will make that a positive 3. So now I'm solved for y. So now I would come in and actually pick 2 points that I can plot on the math lab. So if I got fractions, I'm going to use a 0 for sure. 0 times 4/3 is 0. And 0 plus 3 gives me a 3. Now, y'all, here's what I do on this one. My second x, I'm going to pick a 3 because it'll cancel that denominator. So let me show you why I'm picking 3. Because right here, that 3 divided by 3 will cancel, making that a 1. So this is now 4 times 1, which is 4. 4 plus 3 gives me 7. So when x is 3, y is 7. So if I got fractions like this, I always pick my second x. That'll be a number to cancel that. All right, I got 2 points now. Now y'all realize when I graph it, this is the equation I'm going to model it from. Not this one, but the one where I got it solved. That means I'm going to use the greater than or equals, okay? You cannot use the less than because this one wasn't solved yet. You got to get it solved, then determine your inequality, okay? So mine's going to be greater than or equal. So it looks like I'm going to use a solid line and I'm going to shade above. All right, y'all, let's go plot those 2 points. So I'm going to click the enlarge graph. Now, by default, it's on a solid line like I need. So all I need to do is come up here and choose the 2-point line tool. Plot my 2 points. I had 0 up 3. And then I had 3, right 3, and up 7. So I got my 2 points. I got a solid line. It was greater than or equal. So I'm going to grab the region shading tool and drag it above the line and click. All right, so once you've done that, you're going to save it and then check your answer. All right, now these ones are special lines. So let me write this one down. This is x greater than 2. Now in support, it'll actually do 2 lines that we graph for support, and they'll be equals. This one's greater than, but in support, we'll actually use equals on them, okay? All right, y'all, so this is going off of this little pattern here. X equals A. So this is just a general form of this type of an equation. And I'm using equals instead of inequalities. But this x equals A is a vertical line that crosses the x-axis at the point A, comma, 0. So these are vertical lines that cross the x-axis at x equals 0. So if you're going to make a table of this, since this is a vertical line, that means every one of these x values is going to be 2. So we don't care how many points you pick, but every single x value will be a 2 on this, okay? And y'all really, since it's a vertical line, it don't matter what the y values you pick here. You can pick any two y values you want. You can do 0, 1, 1, 2. You can do negative numbers if you want. It don't matter. We're all going to have the same vertical line when we're done, okay? So on this graph, the x values must all be 2. We can choose any two y values that we want. So y'all, I'm stuck on zeros and ones because they're easy. So I would just put a 0 and a 1 for those and be done. Um, but when you're graphing this, so y'all, I picked 2 zeros, so right 2 and 0 stays there. And then I had 2 1, so that'd be right 2, up 1. So right now I got my vertical line. So you could have picked 2, -1, 2, -2, 2, -3. You could have did 2, 5. It don't matter. As long as that x value is a 2, your line will be a vertical line like mine, okay? Alrighty. So on mine, I do not have an equals under it, so I would use the dashed line. So I would make my vertical line dashed. Y'all, so when it's X's, you don't really have an above the line or a below the line. So you just got to figure out, are the X's greater to the right or are the X's going to be greater to the left? Because remember, in math, a vertical line wouldn't even be a function anyway. Um, but X's are greater to the right and they're less to the left. So since this is saying the X's have to be greater than 2, we would drag our paint can over here and shade to the right. That means anything in the shaded area would have an X value greater than 2. Like anything here would be 3. All these would have X's of 4. All these would have X's of 5, and so on. So on the X's, they're greater to the right, they're smaller to the left. So y'all, we want to graph this in Math Lab now. So we would go back to the Math Lab. So on this one, I click to enlarge the graph. And really, since it's x greater than 2, I'm going to grab my dashed line because there's no equals. Then I'm going to grab the 2-point line tool. And then I just come and find 2, 0. And then I can go up and do 2, 1. And it's drawn my vertical line. All right, then I said you would shade to the right for greater than. So y'all click on the right side of your dotted line, save that, and then check your answer. Now look at this one. This one is y greater than or equal to 6. So this is the second of our special lines. Okay, so my other one was when I had a x equals. This one is y equals a. When I got the y equal to a number, this is a special line, but it's not vertical When it's a Y, it'll be a horizontal line. So this is a horizontal line that crosses the Y-axis at 0, A. Okay? So whatever A is 6, that's where it's crossing that Y-axis at. So remember, these are horizontal lines going left to right. Now, on this table, it's similar to the X line wall go. Because notice, you don't have an X variable here. So that means that every single Y value will be 6. Okay, so that's the beauty of a horizontal line. Horizontal lines all have the same Y value, okay? So that means every Y value must be 6. We can choose any two X values that we want. So just like on the X's were the same. We choose 0, 1 if we wanted. Here the Y's are all the same. So you could use 0, 1 for your X's. You could use 4, 6. It don't matter what X value you plot. We're still going to get a horizontal line. So let me go about 7 on this one. All right, so there's my X and my Y. So 0, 6 will be 0 on the X's up to 6. So that's what we said. It would cross the y-axis at 0, 6. And then 1, 6 will be right 1, up 6. So you could have did 2, 6, 3, 6, negative 5, 6. It don't matter. As long as the y values are 6, you'll get a horizontal line. All right, so for this one, there's equals under it. So I would choose the solid line going across there. It's greater than, so I would grab my paint can and I would shade above the line. So any Y value that got shaded would be greater or equal to that Y value of a 6. All right, y'all, so we would go plot that real quick in MathLab. So I'm going to click the enlarge graph. All right, so I'm on solid line by default. I'm going to choose the 2-point line tool. And then since it's y greater than or equal to 6, I'm just going to go up to 6 on the y-axis, click. And then I usually just go 1 right and click. I got my line. Now I have to shade above it. So I'm going to grab that paint can and go above the line and click. All right, y'all. So now we've got that and plotted. And then what? You check your answer. All right, y'all, let me write this one and then we'll knock this one out. This is the only problem that involves a system of inequalities. So I got y greater than or equal to x plus 5. And then I got y less than or equal to 4 minus x. Okay, so now this was what we would call a system of inequalities because it's got two equations. So the solution to a system of inequalities is the region of the graph where the two shadings overlap. Alrighty, so I'm going to shade one graph. Then I'll come in and shade the other graph. Where they overlap is the solution to this problem, okay? So you would take your X and Y axis. All right, so let me come down just a little bit on that. So since I'm going to go out about 10, all right, y'all. So the trick is to graph each one of these. So first, let me start with this one. Y greater than or equal to X plus 5. So for each of these, I just need 2 points. So y'all, I'm just going to use 0 and 1 again. 0 for X, 0 plus 5 is 5 for that Y value. If I use a 1 for X, 1 plus 5 gives me 6. So I'm going to graph the first line first. So I got 0, 5. Then I had right 1 and up 6. Now, both of these have equals on them, so both lines will be solid. So my first line is going to come up through there like this. Now, for the first line, it's greater than. So for greater than, um, I would shade above the line. So for my first line, I'm going to shade it green. And so that's my first line. Now I'm going to plot this second line here. So that one was y less than or equal to 4 minus x. All righty, y'all. So let me see. I'm going to do 0 and 1 again. They're pretty easy. So 0, 4 minus 0 leaves me 4. Then if I put a 1 in there, 4 minus 1 leaves me 3. This is a solid line again, and it's less than. So let's plot our points. We had 0, 4, and then I had right 1, up 3. All right, y'all, so that was a solid line coming down this way. I said it was less than, so it's going to shade below the line. So that's going to shade all this to the left of that line is going to be shaded a different color for me. So remember, we said the solution is where the two shadings overlap. Well, this section right in here, I got green and orange shadings overlapping. So the only solution for this problem would be this section right here where they overlapped. So in MathLab, it'll have 4 pictures of all these sections. It'll have this one highlighted, this one highlighted, this one highlighted, or this one highlighted. We need to pick the one that matches what we got with the double shaded region on the left side. So y'all, that one is all you had to do was choose to answer. So mine was on the left side. So mine looks like B up here. So A was on the bottom, C looks like the top, and then D was on the right side. So we had the left side, so we choose that and then check our answer. All right, y'all. So question, any questions on those? All right, y'all. So let me show you your support real quick. And these are real quick because they're just doing the straight lines. So let me share that. Let me go to MathLab and do the support real quick. It was just 2 questions in the support. And it's just graphing straight lines like this one. Y equals 3. Click the enlarge graph. Remember, y equals 3 was a horizontal line crossing 3. So on this y equals 3, I would click the line tool, go to 0, 3 on the y-axis, and then right or left. It don't matter what point you pick second. Say I could go to -7, 3 and pick that. As long as I got a horizontal line crossing at 3 on that y-axis, okay? Now these you didn't have to shade in support, you just had to draw the line. So you graph that one, check answer. And then the other one's going to be, it's going to ask me, what is the slope of a line? Well, y'all, every horizontal line like that, it don't have a rise or it don't fall. So every horizontal line will have a slope of 0. Just like the floors you walk on, right? They have 0 slope uphill or downhill. So I just wanted you to write the slope and then check your answer. Now this one, all you had to do is choose which one of these is the graph of x equals -2. So y'all, let me make these a little bigger for you. Also, the first thing you got to realize is x lines are vertical. So y'all, A, B, C, or D, which one of those would be the graph of x equals -2? All right, let me see. Y'all are starting to write. B, good job, y'all, because remember, x equals a number is a vertical line up and down, and it crosses the x-axis at -2. And y'all are perfect because B looks like it's crossing at -2, and it is a vertical line. So check that and be done, y'all. So this homework was just getting you used to vertical and horizontal lines so that when you did the college algebra homework, you know what kind of line to draw on those situations, okay? All right, y'all. So y'all got about 7 problems to do tonight for this homework.